Okay, so picture this. What if your phone could diagnose an illness, like way better than anything out there, but get this, your data never actually leaves your device?
Well, that's the kind of future we're talking about today with 6G and federated learning.
And that's exactly what we're diving into this whole world of 6G and how this revolutionary approach to data, called federated learning, might just be the answer to keeping our data safe in the hyper-connected future.
Yeah, and what's really mind-blowing is that we're not just talking about faster internet here. 6G is going to connect practically everything around us, which is going to create this like massive web of data exchange, something we've never seen before.
Right, and that's where our research paper comes in. It's called Federated Learning Enables 6G Communication Technology. And it basically lays out the roadmap for this super connected but hopefully privacy conscious future.
It's a real glimpse into the cutting edge, and you're right. The level of connectivity that 6G promises is unlike anything we've seen before. Think self-driving cars, doctors doing remote surgery from like different continents, maybe even those holographic calls straight out of Star Wars could be a reality.
Okay, hold up, holographic calls. I can barely handle video calls with my internet connection as it is.
Think 3D video calls, but way more intense, like you're interacting with a real-life projection of someone as if they were actually in the room.
Okay, I'm starting to get a picture, but now imagine this. A world completely overloaded with devices, all constantly sharing information at ridiculous speeds. How do we make sure our privacy isn't completely lost in all of that?
And that's exactly where federated learning comes in. It's about finding that balance between the amazing potential of being connected to everything without, having to sacrifice the security and privacy of our own information.
Okay, so walk me through this. How does federated learning actually work? It sounds kind of like magic, honestly.
Okay, imagine you're trying to perfect a recipe. Let's say it's the world's best pizza. Instead of everyone sending their secret ingredients and methods to, like, one central chef, what if they could all work together without ever giving away their full recipe?
Okay, so less big pizza controlling everything and more like power to the people kind of thing.
You got it. In federated learning, your phone, for example, becomes like a mini chef. It analyzes your data, but only locally. Then it shares just tiny, totally anonymous insights with a global network. Imagine it's like adding a pinch of oregano or a sprinkle of chili flakes to the overall recipe.
So my phone's constantly learning and getting better based on data from other devices, but my actual data, like my secret pizza recipe, never leaves my phone.
Exactly. And here's the best part. This whole learning process happens in a way that keeps your privacy protected. And this is a big deal because those privacy measures we have now, like anonymizing data, they don't always cut it, especially with the insane amount of information 6G is going to be thrown around.
So we're talking about a potential privacy revolution here, like actually having incredible technological advancements without having to sacrifice our data. That's huge.
It really is a game changer. Think about healthcare, for example. The research shows that this could totally change the game for medical research. Imagine hospitals around the world being able to analyze patient data to develop new treatments, all without ever compromising anyone's privacy.
Speaking of healthcare, just imagine getting a diagnosis from an app on your phone, but it's way more accurate than anything we have now because it's learned from millions of other cases. But your information stays on your device. That's the kind of future we're talking about.
Exactly, and it doesn't stop at healthcare. Think about education that's personalized to how each student learns best, or cities that can manage traffic without needing to know everyone's exact location. The possibilities are pretty much endless.
This is starting to feel less like a tech upgrade and more like a fundamental shift in how we think about data and what we can do with it. But we're not just talking about hypotheticals here, right?
Definitely not. This research actually highlights some real-world examples that are already being developed and tested as we speak.
Okay, so give me an example. What would this look like in action?
Okay, so picture this. A network of self-driving cars, all linked up through 6G. Now, with federated learning, each car basically becomes its own little learner, picking up on stuff from every trip, how to handle crazy weather, swerve around unexpected obstacles, all that jazz.
So it's like each car is running its own driving school. But instead of sharing like actual footage from the road, which would be a whole privacy nightmare.
Exactly. They're not sharing raw data. They shared, what they've learned, but in a way that doesn't put anyone's privacy at risk. Each car contributes to this kind of shared knowledge base, but no one, not even a single company, has access to the full picture.
Makes sense. But hold on, we're talking split-second decisions here, right? Like swerving, braking. How can we be sure this federated learning thing can keep up with that?
That's where the whole speed and responsiveness of 6G come into play.
Hmm.
The research actually talks about this, something called ultra-reliable low-latency communications. Basically, the faster and more reliable the connections between devices, the smoother those cars can share what they know and react in real time.
Okay, so like a super fast, super secure data highway where everyone benefits, but no one's personal info is compromised, that's pretty wild. But realistically, there gotta be some bumps in the road. Like, how do we even know this federated learning thing can work on such a massive scale?
Oh, absolutely. One of the biggest challenges is making sure that shared model is actually accurate and reliable. If
Ugh.
you've got millions of devices all throwing in their 2 cents, how do you guarantee the final result, the recipe, isn't a total mess?
Right, like if someone accidentally puts salt in the pizza dough instead of sugar, it's gonna throw the whole thing off. How do you prevent that kind of stuff from happening in federated learning?
And that's where things get really interesting. Researchers are developing these super smart algorithms designed to spot and get rid of inconsistencies in the data, or even, potentially malicious data. Think of it like a quality control system for information, only letting the most accurate and trustworthy stuff through to that final model.
Okay, so we've got quality control down, but what about security? With all these devices hooked into this network, there must be some vulnerabilities, right? Couldn't someone, like a hacker, mess with the system somehow, feed it bad information, or even steal data?
You're spot on. That's another big challenge. Experts call them adversarial attacks. They can be pretty subtle, like nudging the model's output in a certain direction. But in a worst-case scenario, you're talking about trying to swipe data or even take the whole system down.
Okay, yeah, that sounds a little unnerving. So, how do we even begin to tackle something like that?
It's a multifaceted problem, for sure. And researchers are coming up with some pretty innovative solutions. One thing they're working on is something called homomorphic encryption.
Homomorphic encryption. Okay, you're gonna have to break that one down for me.
Imagine a lockbox for your data. You can put your data in, do calculations on it without ever having to unlock the box, and then you get the results in that same encrypted form. That's basically what homomorphic encryption does. It's like doing math on encrypted information, making it way harder for those bad actors to get in.
So, some serious next level encryption. It's good to know these safeguards are being developed, but are they foolproof? Is there any way to guarantee that federated learning will always be secure?
That's the million-dollar question, right? The reality is, just like with any technology, it's not entirely immune to vulnerabilities. While researchers are coming up with new ways to make it safer, there's always going to be someone trying to find a way around it. It's a
Yeah.
constant back and forth. But the potential benefits here are too big to ignore.
It's like a high stakes chess match, with the future of data privacy hanging in the balance. But it sounds like researchers are developing some pretty powerful tools to stay ahead of the game.
Exactly. That's what makes this whole area so fascinating. We're talking about completely changing how we think about data security in a world that's becoming more interconnected every day. It's a huge challenge, no doubt, but the payoff could be enormous. We could be looking at unbelievable advancements in pretty much every field: medicine, transportation, education. And the best part is, we can do it all while protecting one of our most valuable assets, our data.
I'm getting the feeling there's a but coming here.
You know me too well. Look, it's super important to remember that all this potential comes with a responsibility to make sure we develop and use federated learning ethically and thoughtfully.
What do you mean by that?
It's not enough to just nail the technical stuff, right?
Mm.
We have to make sure that federated learning actually benefits everyone, not just, a select few.
So it's not just about building the technology itself, it's about building it responsibly. What would that actually look like, though?
Well, for one thing, we need to address those potential biases that can sneak into the data. Like, imagine a federated learning model trained on data that doesn't really represent everyone. That could lead to some seriously biased outcomes. We've got to make sure those data sets are diverse and inclusive.
Right, it's like they always say, you put garbage in, you get garbage out. So how do we guarantee we're giving these systems good, clean, unbiased data?
It's going to take a multifaceted approach. I mean, researchers are creating techniques to detect and fix bias in data sets, but it also takes like a conscious effort from developers and companies to make fairness a priority from the get-go.
So it sounds like there's a huge responsibility here, not just for the tech geniuses building these systems, but for like policymakers, everyone, really. We all need to make sure this technology is used for good.
100%. This is way bigger than just one company or one industry. It's about shaping the future, and that's a team effort.
So we've covered a ton of ground here today, from the incredible potential of federated learning to some pretty big challenges. But as we wrap up, what's the one thing you really want our listeners to walk away with?
If there's just one thing, it's this. The future of data, it's not set in stone. We have the power to decide how we want to shape this technology and ultimately how it shapes us. By staying informed, asking tough questions, and expecting more from the companies we deal with, we can help make sure that data is used to empower, not exploit.
I love that. A call to action. So don't just sit back and let technology decide the future for you, all right? Get involved, stay curious, and help build the future you want to see.
Couldn't have said it better myself. The future of data is in our hands.
And that's a wrap on this episode of The Deep Dive. A huge thank you to our expert for breaking down this complex and honestly pretty mind-blowing topic. And to everyone listening, thanks for joining us on this journey into the future of data. Remember, stay curious, stay informed, and we'll catch you on the next Deep Dive.